Hi everyone. So if you were just watching the video previous to this one, you would have noticed that it cut off very abruptly. So when it did that, I wasn't sure, what was going on. I thought maybe there was like a time limit or something, but then I realized I had literally ran out of memory on my computer. Like, because I've been recording so many, videos that just with everything else on my computer that I literally had no more room. So I had to go through everything and delete a bunch of old stuff and move some old other stuff. And anyway, so um, we're going to continue with the second half of this. It's kind of nice to have kind of two videos for this one anyway, because it is a little long. So let's see. And there have been a couple days between when that video I recorded and this one. So I'm trying to think. I think I remember approximately where we were, which is fine because, we're not going over every single little bullet point in the PowerPoint that's there for you to, use, peruse at your own, discretion. But let's start at, if you're following along on the PowerPoint, let's start at slide 28. So you'll see there are like two, I think those are geladas, the monkeys. And then what appear to be some kind of deer. So you'll see here that the title says intra-sexual selection, so males fighting. So recall earlier on in the other video, the first part, where I discussed intra versus inter, so the difference between when we're talking about sexual selection, sometimes we're referencing the interactions between males and females. Like, of course, in these scenarios, we're always talking about heterosexuality. We, of course, know that in nature, in multiple species, that there can be homosexuality. But when we're talking strictly about like evolution and reproduction, obviously we're talking about, male and female. So in terms of interactions, sexually, there could be interactions between what's going on with the male and the female. We talked before in the previous video about how, there's a strategy for one of them and then a counter strategy and then a counter strategy to the counter strategy back and forth. And how, like, that's kind of how nature works. Now, of course, there's going to be variation depending on what type of species you're looking at. If you're looking at a species that has a high amount of sexual dimorphism, which of course means there's a high amount of competition, or a moderate amount or a low amount, right? So how the interactions between the males and females play out will be based kind of on that social mating system. And then, of course, with intra, this is, within a particular sex. And when we reference this, it's almost solely meaning within males, like males to males. What are the interactions amongst males, specifically in reference to their access to females? The males fighting with each other in some way. So are they physically fighting? Are they actually, using like their teeth to bite into each other? Do they do more of a display? And they try to see who has the better display. Are they throwing each other off a tree, like whatever the case may be for that particular, species. So you'll see there's the image I already pointed out. So if you go to the next slide, you'll see another example. So we have two male lions fighting, and we can use any animal from nature, but using primates is always really interesting because we have this nice, wide variety of, different social mating systems. So we have those that are monogamous, those kind of in the middle, like, humans or chimps, and then those at the extreme end. So you can really see the nice variety. And so gorillas are always a really good example of the male to male competition, because for gorillas, they have what's called a harem system. Remember, they have a high amount of sexual dimorphism. Males and females look insanely different. In fact, if you didn't know what gorillas looked like, what they were, and you, let's say, came across a female gorilla skull and then a male gorilla skull without knowing anything else, you might look at those two skulls and think you were looking at two completely different species. So that's how drastically different they are. So it's interesting to see kind of how those things play out. But so they're in a harem mating system because, remember, high dimorphism means high competition amongst the males, which means like non-monogamy to some varying degree. And so for the male gorillas, when they fight each other, it's not as if the loser gets, one female or two. It's all or nothing. The males who win or continue to win and maintain their female group have access to like 5 or 6 females, like, or, 4, 5, 6, something like that, depending. There's going to be variation in that. And plenty of males get access to 0. So there's a lot riding on that, like evolutionarily and reproductively, right? So the competition is so intense and so high, which is why the males look drastically different from the females, because selection is, it's selecting them to be like larger, bigger, sharper canines, whatever the case may be. And so we see this interesting interaction amongst the males. Sometimes they'll just like beat their chest in the jungle, and you'll hear this really loud, like, sound. Then maybe make a call, and the other male might think, ooh, I don't think I want to fight, or in a physical like confrontation, maybe they're kind of sizing each other up a little bit. You'll see that with a lot of animals, primates included. They're like, what are we going to do? Maybe they're snarling at each other. And in primates, we're going to get to this in just a second on the PowerPoint, but in primates, the canine teeth are really important in terms of sexual selection. It's like their main thing. And so they might bare their large canine teeth, the males, to other males, to show like, are you sure you want to fight? Look at my teeth. I might, so one of them might just be scared off by that alone. And then of course, if they're not, then there's a physical interaction where they will fight each other, grabbing at each other, ripping things, biting into each other, etc. So very, very interesting. Let's see, slide 30, you will see just a couple more examples, some images. We see the human example, and then there's some rams. So depending on the species you're looking at, you're going to see this play out in different ways, and not even just the physical features that they might use, horns or teeth or, whatever it is. The varying degrees of how intense it might be, it could be very intense where death is common, or it could be, maybe not as much. So there's a lot of variety. Even if we're just talking about just primates, there's a lot of variety. And especially if we're talking about like, all of mammals or something, a lot of variety. Slide 31, just again, a handful more examples of some primates. The gorilla, you kind of see them, they're like sizing each other up. They're probably about to, get into it. The male humans are, kind of doing the same. They're like, what's about to happen. Slide 32. So this is when we get into a topic that I already mentioned earlier in, I think it was the first video for sexual selection, which, it's been a few days. I think I kind of sort of explained it, but here we have the slides, kind of dedicated specifically to it. So you see I'm using a different mug today. I've got the dog mom. Oh my God. I totally forgot. Give me 1 second. Okay. You all are very lucky because you have a teacher who this year has won, I don't know, hopefully you can see that, the distinguished part-time faculty of the year for 2025 and 2026. So this isn't just in anthropology or just in the human behavior department. This is camp, like CSN wide, amongst those who are adjunct, myself, and I won. I won the award. And you have to get nominated for this, and then once you find out you're nominated, you have to like submit, basically some info about yourself, and other people kind of, do that in their nomination, for you. So it's just so amazing. There was a award ceremony earlier in the week, and like the handful of us who knew we were nominated, who had kind of made it to like the final round, we all knew that we were supposed to be there for the ceremony. And so, we're all waiting, and I'm thinking, okay, I've made it to like the top, like the last handful. I think there was like 15 of us. So amongst, everyone who was nominated, we're like in the top tier. So that was already pretty cool. And then they called my name, and it was just such an incredible experience. I just felt so honored and excited. And later that day, my partner and I, we went out and had like margaritas, and it was a lot of fun. But yeah, this beautiful, I don't know if you can really see it on the video. It's clear, but there's this beautiful like blue, and when the sun catches it, it's just the whole thing looks blue. It's just so beautiful. So I'm just like so proud of it. So pretty cool. I don't even know what brought that to my mind, but that's okay. So back to sexual selection. So here you'll see on slide 32, you can see a really great example amongst primates. So one of my favorite primates ever, the mandrill. If you've ever seen The Lion King, or the different versions of it, the character Rafiki, if I'm remembering correctly, is that's his name, right? Rafiki. That's based on this particular primate. So you see the male is the one with all this very beautiful and elaborate coloring on like the snout, right? Red, blue, yellow. And the image here on the slide is a good image to show you like the male versus female, but in real life, the male, it's even a little more vibrant than this image is showing. It's very beautiful. You can like Google it. It's very beautiful. In fact, I have the mandrill, I think, a little bit throughout some of the primate stuff for this course too, because it's just my favorite. But you'll see here on this side by side, the male is significantly larger than the female, right? The coloring is different. The female has sometimes a little bit of the pale blue and some of the yellow, but doesn't have any of the brighter blue or the red at all. And it's kind of cut off on the top of the head, but the male, the bone structure of the skull is significantly larger than the female, so you can't obviously see the bones, but you could see like the top of the head in the female is just kind of very flat, and the male it's kind of going up like this. That's not just the hair, that's the actual bone structure. So sexual dimorphism, as the definition is right here, that is when there is a difference between a male and a female of the same species based on either size, shape, or color. Now, for a species like the mandrill, it's all three, right? They have a color difference, they have a size difference, and they have shape difference, like with their skeletal structure. So, but some animals, primates, mammals, whatever, may have a massive difference, like the gorilla or the mandrill. They might have a moderate amount. So humans and like chimpanzees are a good example of like having a moderate amount. You can definitely tell the difference like physically, morphologically, between like a human male and human female, or like a male chimp and a female chimp, but it's not as extreme, as like a gorilla, let's say. And then at the very other end of the spectrum would be those who have basically no dimorphism at all. And when a species has like zero dimorphism, they're called monomorphic. And a good example amongst primates is the gibbon. They're the ones who, use their arms to move about in the world. That's called brachiation. And you can't tell unless you look at their genitalia. They come in kind of a variety of colors, but kind of similar. I think I gave this example before, kind of similar to like house cats. You might have a cat that's black, or a tabby cat, or a white cat. The color is unrelated to whether they're male or female, right? Even size, it's unrelated. You literally have to look at their genitals to be able to tell. So a gibbon is the same way. So you see amongst primates or mammals, you're going to fit somewhere along that of either like very, like none or very little, a moderate, amount, or an extreme amount, And so here you can see with the mandrill, like I said, it's kind of an extreme version. And all three of those things, size, shape, and color. Not every species, even if you're like, oh, the size difference is crazy, maybe there's like zero color difference, right? So what's going to present, depending on the species, it could be all three of those things in a moderate amount. It could be all three of those things in a large amount. It could be just two of them in a large amount. You know what I mean? So every species is going to present a little differently. Let's see the next slide, slide 33. So this is showing size difference, just to make sure you're understanding. So this is the baboon. You guys are probably very familiar with the baboon. You see the male and the female. Literally, you can see the male is drastically larger than the female. This is often when we see in primates, when we see sexual dimorphism. Size is kind of the big one. We see the shape and color, of course, but because size is also a very good like a visual, especially when the male is significantly larger. So in gorillas, a female gorilla is usually around like 200 to like 250 on average. Male gorillas are usually around 400. So pounds. So male gorillas are literally like twice the size of the female gorilla. Whereas like say in a human, males aren't double the size, but there's like a certain percentage on average, that they're larger. The next slide, shape differences. So like I was saying, this when we talk about shape difference, typically this is a reference to like the skeletal shape, and it can be in the pelvis. Like in humans, pelvis is a big one, but in a lot of other mammals or primates, a lot of the shape differences occur in the skull. So you can see here, this is showing the gorilla male and female skull. And like I mentioned before, if you had just seen these two without knowing anything else, you're just looking at these two images, you might think you're looking at two different species, right? But in reality, it's the same species. It's just there's an intense amount of sexual dimorphism. So you'll see the female skull, like the top of the head is kind of just, smooth. But the male skull in the top and the sides has these extra like bony prominences. So the one like in the middle is called like the sagittal crest. That's going to be a term we talk about later too. Basically, for the gorilla male, and this is true for like even like humans or chimps looking at the male, especially the upper body and like the neck area, has a lot more like musculature than the female of that species. And so the muscle all attaches to bone, right? Well, if the muscle is very large, the body sometimes has to kind of create a little bit of extra bone for that muscle to have something to attach to. So this is why that and if you watch the video on like sex determination in humans, you'll for this class, I talk about it in a little more detail about looking at the male female like skull differences in humans. But in general, whether it's the human, the gorilla, the chimp, whatever we're talking about, males have that larger upper body strength. A lot of the muscles like of the chest and neck come up and attach onto the head. Like you have one, it's a very prominent muscle we all have. It's called the sternocleidomastoid. So that starts kind of down here at your clavicle and comes all the way up your neck and attaches actually to like behind your ear. So a lot of those muscles attach, the ones up your back, like your trapezius and stuff, those all come up and attach to the back of your head. And so if those muscles, as in males, they're often very large, the body will often create extra bone in some way, whether that's more of a rough appearance to the bone, a little bony overgrowth. In this case, you see the gorilla has all these crests. That is because the muscles of like the back, the neck, the chest are all so insanely big that the body has created extra bone for it to attach to. So that's where we see these shape differences. And then slide 35, you see the color differences, right? So once again, I'm using the mandrill. It's a really good example. I love the mandrill. You can see the male and female. Female does have a tiny bit of coloring, but the male has the very elaborate coloring. So depending on how this might play out, depending on the species, right? If we're talking about mammals, if we're talking about birds, there could be an extreme color difference, or there could be maybe just like a moderate color difference. It's going to be dependent on, that particular species, which is why you're going to see like this incredible, part of nature, the variety of coloring that you see. But when you see a difference in coloring, it's always the male who has, more of the coloring than the female. Let's see, slide 36. I'm like, I need my glasses for this part. Let's see. Let's see. My glasses are kind of crooked. Oh, I think I already kind of said all this mostly. Oh, the secondary sex characteristics. So I'm pretty sure I mentioned this in the first part, but secondary sex characteristics are the features that develop during and after puberty. So your primary sex characteristics are like your genitals, internal, external. But for the secondary sex characteristics, those are the features that occur, like I said, during and after puberty. So for a female, that would be like the breast getting larger, the fat distribution in the hips and the lower tummy start to form, right? So you get more of like a curvature to the female body, and in every female, let's say we're talking about humans as an example, there's going to be variation, of course. Not every female has the exact same curvature, some a little less, a little more, but that's when that process starts. So those are secondary sex characteristics. So depending on the species, that could be when a certain color develops. It could be when a certain, part of the body gets larger, for male humans, you see the upper body, like the chest and the upper body becoming larger, more muscled, etc. Those are just a couple examples. And depending on the species you're looking at, primate or other mammal, it's going to be, different depending on what their version of puberty is, what the features that kind of pop up during puberty. They could be minimal features, they could be very extreme features. It's just going to be dependent on that, particular species. And those are indicators to the opposite sex, like that's a potential mate because now they are at reproductive age. So in humans, we are reproductively available, like let's say in nature, evolutionarily, at about age 14. So you want to look at the onset of menstruation. So, menarche. When is that first menstruation? Usually, you get your first, as a female, you get your first ovulation about a year after. So I think right now the average age for, like, let's say humans in like the US, I think the average age for females, menarche is, I think it's like 12 years old. It could be a little lower, a little higher, but let's just say it's 12 years old. It's about a year later, so we could say like 13, 14, something like that, would be when they're technically like reproductively available. Now, you might be thinking, wow, it's very young, because obviously we have decided culturally that that's very young. You're still a child. Just so your brain is still developing for like another 10 years after that, right? And so we've decided culturally, of course, depending on kind of where you live, that age of when it's more appropriate to maybe start having offspring is a handful of years later. It could be 3 or 4 years later, maybe 4 or 5 years later. I think the general in like Western culture is, ideally you probably graduate high school, but we see plenty of times that doesn't happen. It's because we are technically, reproductively available and functional at a younger age. Now, of course, for every individual, it's going to be a little bit different. You could have your first ovulation at let's say 14, but your body in puberty, it's still kind of in other ways is, because it's a long drawn out process, right? So you could have your first ovulation, but your hip structure might still be narrow because that part's kind of still developing. So it's not as if at 13 or 14, everyone is perfectly reproductively available. It's like, 100%. Of course not. It's a process. You could say in a general sense at about age 14, it's kind of like some of them it could occur, but a lot of times, and we see this in younger individuals, those who, let's say females who do get pregnant at that very young age of like 13, 14, 15, a lot of times there can be complications because the bone structure in puberty is still kind of developing. So this isn't to say every single female human at 14 is ready. Like that's just kind of in nature, like when that is plausible, and a certain maybe percentage of the population, it would be, plausible for it to happen, functionally. But it's still kind of a process. Let's see, the next slide. Just more examples of sexual dimorphism, size differences. We see the lions, color differences. We see some birds. The next slide as well, we see some size differences with the humans, and then we see the orangutan, a really interesting like secondary sex characteristic feature. The males get this big phalange thing, like in one of the subspecies of orangutans. The males get this like a fleshy thing, and it's supposed to help, I think, with like, oh, hold on, I want to say it helps with some kind of like vocalization or fighting. Let's double check this. Orangutan flange. Okay. Oh yes, so it does have something to do with like the calls they make. And apparently it is also a sign of a higher social rank. So this happens too with like gorillas. The silverback, it doesn't necessarily occur like for every male. So I think sometimes there's other signals with like coloring or other physical, like secondary sex characteristics. Very interesting. Let's see, 39, slide 39. So this is what I've kind of mentioned a few times, the connection between the amount of sexual dimorphism and the particular social mating system. So it's really easy to remember this part. And this will help you inform on like most of the other parts of how sexual selection works. When there is a high amount of dimorphism, whether that's size, shape, color, or all three, or two, or one, doesn't matter, when there is an extreme amount, what that means is there is also an extreme amount of competition amongst the males over access to females. And what this means is that means it's a non-monogamous system. When there is a low amount of dimorphism, and so you can't really tell the difference between a male and a female, this is directly related to a low amount of competition. And what that means is the male and the female of the species just kind of naturally pair up. Unfortunately, in the past, some students, not a lot, but a few, have misunderstood this point, so I want to make sure I'm very clear. And I think I mentioned this on the previous video, but I'll say it again. A species that has low dimorphism, like the gibbon, I keep using that, it's a good example, and they're pictured here on slide 39. There's a male and a female, but you can't tell by looking. I mean, you have to look at their genitals to be able to tell. When there is a species like that, where there is a low amount of dimorphism, and hence a low amount of competition amongst the males, because they don't really need to fight with each other, the male and female just naturally pairing up in monogamous pairs. This doesn't mean it's unrelated to like their libido or how many offspring they can have. For some reason, some of the students in the past, like I said, just very few, but it's come up a couple times, where they have somehow equated, oh, if I'm not competing with another male and I'm just naturally pairing up with a female, then that must mean my libido is low and I produce fewer offspring. I'm not quite sure how that connection is made, but it's come up more than once. So obviously there's something being connected that's not really there. So just like I said, if the males are fighting all the time in one species, but they're not fighting all the time in another species, that doesn't mean the species where they're not fighting, they're gonna like die out because they're not making babies. Like, that's not how that works, right? It just means they're pairing up in monogamous pairs, and so the males don't have to really compete with each other because the females and males are just like, oh, we're a pair, oh, we're a pair, oh, we're a pair, versus in the others, they're not pairing up. There's a high amount of competition, so the males are fighting with each other to see who gets the female or who gets more than one female. So neither one of these is good or bad, better or worse. They're just different strategies of mating. That's it, right? So it's unrelated to like the libido of the female or the male. It's unrelated to how many offspring they're going to produce. Like, that's not part of it. So if you were kind of thinking that in your mind, it's not part of that. That's totally unrelated. Let's see. And so you'll just see here, like I said, I have the examples of the gibbon and the gorilla on slide 39, kind of showing the difference between when there's a species that has basically zero dimorphism and a species where there's like a lot. You've got a monogamous pair, so you've got a monogamous pair over here, and then with the gorilla, the species where there's a high amount of dimorphism, you see one male with like 5 females. So that's the difference. So slide 40, something to consider, which I already mentioned the previous one, is that idea of serial monogamy, right? So you have species at one end of the spectrum. If we're talking about just primates, we've got the gibbon on one end. Sorry. They're naturally pairing up in monogamous pairs, basically for life, for the most part. And so there doesn't really need to be any competition amongst the males because everyone gets a partner. And so the males don't have to be larger to compete with each other, right? So the male and female of that species is around the same size. Versus like with a species like the baboon or the mandrill or the gorilla, right? They're not monogamous. The male competition is high amongst each other to get access to the females, right? They might have a harem system. They could, like, the systems might differ, but they're not pairing up. So a lot of males in those systems don't get to mate. And then you have species, like I said, like humans ourselves, or like the chimpanzee, plenty of others as well, where we're kind of in the middle. And so that the question is, are species like humans naturally monogamous? And of course the answer is no. Absolutely not. In terms of how we define monogamy when we're talking about nature, usually when we say monogamy in nature, we're talking very specifically about like lifelong or close to lifelong monogamy. Humans are very good at kind of the middle, right? Because we're kind of in the middle sexually dimorphically, just like chimpanzees, we're kind of in the middle. So we're really good at kind of an in the middle mating system where we are really good at being monogamous, like being faithful in a particular, relationship. But we tend to have several of those over the course of our lives. So that's true for like humans or other species kind of similarly like chimpanzees. If the dimorphism is kind of in the middle, it means the social mating system's kind of in the middle as well. So as humans, we're really good at being faithful, to our partner. We just tend to have more than one partner in our life. So like I mentioned before in the previous one, don't let people say like as an excuse, like, oh, well, we're just meant to cheat because we're not naturally monogamous. Like that might be your personality, but that's not based on anything evolutionarily at all, so. Slide 41, you will see that the font is very large and there's a star. I mentioned this earlier in one of the other videos. In this class, upon reflection and say in a decade, you're thinking back about this cool class you took with me and you're like, what do I really remember from that class? This should be one of those things you remember. It's very important. And from this will guide you in a handful of other ideas about how evolution works and how primates work. You'll see it here. Large canine teeth among primates are not indicative of meat eating. Now, in a non-primate, this could be directly related, right? If in a non-primate, let's say like a lion, you see the large canines, you're like, oh, that's directly related to what they're eating. And in that case, they're carnivores, right? So they're eating meat. In primates specifically, so human, chimp, gorilla, capuchin monkey, mandrill, gib, whatever, any of the primates, what the canine teeth look like and what the diet is are unrelated. If you want to know, so this is important, if you want to know what a primate is eating, you have to look at the back teeth. So the molars and the premolars, all the teeth in the back where we do all of our chewing. As primates, our molars look very distinct if you're like a primate that eats only insects, if you're a primate that eats only fruit, if you're a primate that eats only leaves, the back teeth tell that whole story. The front teeth in primates, the canine specifically, unrelated to diet of any kind, especially meat eating, not a thing. In primates, the canine teeth are directly related to sexual selection. They are used as a form of display or in fighting. It's completely unrelated to the food. Like I said, this is very important. In non-primates, front teeth, canines, probably directly related to the diet, right? That's true. In primates, that's not the case. In primates, the back teeth tell you everything about the diet, and the front teeth tell you everything about what's going on, like sexually, socially, dimorphically. It's a completely different story. So as some examples of this, you will see the handful of slides that come after. We've got slide 42, the mandrill. Once again, I told you one of my favorites. The mandrill is a folivore. So a folivore is an animal, or in this case a primate, that eats mostly like leaves, stems, even like bark, kind of, depending on the particular species. But you see those giant canines in the male. Depending on the species, sometimes the female canines are a little larger, sometimes not, but it's usually the male where they are just insanely massive. So you see here, this is an animal that eats only leaves. Maybe the occasional, berry or something if they come across it, maybe the occasional insect, but they're eating leaves. That's what they're eating. And the canines, if you didn't know any better, you might look at that and think, oh, they're probably tearing into their food. No, they're just tearing into each other. The males are using them as clearly, you could see in this image, like as a threat display, right? They're snarling, they're baring their teeth. Crazy scary to us and like to another male, mandrill. And then in the event of an interaction with another male, they're going to use that to bite into each other. So for primates, canines specifically related to sexual selection. Once again, on the next slide, you'll see another example. We've got the chimpanzee, a frugivore. The majority of a chimp's diet is fruit. If you look at their back teeth, they look very similar to humans. Their back teeth tell you the story of what exactly they're eating. Chimpanzees won't pass up maybe some insects on occasion for sure, but their majority of their diet is fruit. But you see those giant canines, it's because like humans, chimpanzees have like a moderate amount of dimorphism, so the males do compete with each other over access to females. So that is what those teeth are for. And as a side note, uh, as a side note, if I were to ask you, like in class, usually I ask the students, what's the animal, the scariest animal? What's the animal you fear the most? For myself, it is absolutely 100% the chimpanzee. Very cool, primate, highly intelligent, better at us than in a lot of different ways, cognitively, but very, very aggressive and violent. Some of you are probably aware. I mean, when I was like an adult when this happened. This was years ago, but I'm assuming most of you are pretty young. That there was this famous case, I think it was in the 90s. This woman, this part's so crazy to the story. This one woman had a pet chimp, which is like caging a human. Like, it's completely like unethical. I can't even believe this happened. But of course, no freaking surprise, the chimpanzee attacked one of the woman who had this chimp as a pet, one of her friends, and ripped her face off. And this was the case of the very first, if I'm remembering correctly, the very first facial, like face transplant this woman had. So, I mean, this is a story we could talk about for like an hour, right? Like the implications ethically, morally, et cetera, surgically, all that. But this is just to say, this is not uncommon in chimps that they will literally rip parts of each other's bodies off. And for males, think of like the one part of your body you probably don't want ripped off. The males are known to do this to each other. It has happened. So very cool, interesting animals, but very terrifying in that way. Versus like a gorilla, you might think, well, gorilla's bigger, it's scarier. But a gorilla, if it's gonna hurt you, it's probably just gonna like punch you in the head and then you're done, right? So kind of quick. They're not gonna rip anything off you. So just like food for thought. But anyway, so you see here the chimp canines, it's not because they're eating meat or it's not even related to diet at all. It's directly related to sexual selection. In the next slide, slide 44, you see the gorilla. Once again, we have another folivore. This is a leaf eater. Giant canines, because we know that the gorillas, the competition is very high amongst the males because the winner gets 5 females and the loser gets 0. The competition is very high. And so those giant canines are there for, once again, as a threat display in actual fighting, unrelated to diet. And then on slide 45, you will see an example of like the human, teeth. So you see here that, so evolutionarily, and when we get to the primate section, we'll talk about this more. Evolutionarily, humans would be classified as frugivores because like evolutionarily, like that was the majority of our diet until like very recently. Teeth are what we call evolutionarily conservative. Teeth are a little slower to change than like other parts of the body and stuff. So it's, when you see interesting changes in the teeth, it's always really like worth noting. And so what we see in the human, you see this imagery here, is the canine in humans basically has turned into another incisor, like another like front tooth, right? So like just for like kind of, maybe biting into something, and then, but we still do all of our chewing in the back, right? So our canine is basically not even really a canine in modern humans. It's essentially another incisor. And so you see here, though, even although it's recently, so the teeth, are slow to change, but we've introduced like meat into our diet. So we're technically like, we would say like omnivorous as a species for not quite 2 million years. So a little less than 2 million years. And like, where's the canine, right? So like I said, in primates, the canine tooth is unrelated to diet at all. And it's very specifically, it's unrelated to whether you're eating meat or not. That's not part of it. In non-primates, the canine, if it's really large and sharp, you'd be like, oh, they're definitely eating meat. But in primates, it's completely unrelated to the diet. So the next few slides, let's see. Oh, talk about some interesting, so all of what I've said kind of in the last, whatever half hour has been about when you see dimorphism happening in mammals. But in non-mammals, dimorphism can kind of be interesting and different. So you see in the next few slides, I just have a few examples of this showing like dimorphism in insects. And then in like marine life, even when it's like a mammal, let's say, that it tends to be a little bit different. So in insects, you might see the female being the one that's who's larger, but this is not because this is so important. This is not because the females are competing with other females over access to males. When we see males larger than the females in, like, let's say mammals, right? That's exactly what it's for. But in insects, when you see the female bigger, it's not for that reason. It's not because she's competing with other females. It's very specifically because she has to be protective of her own offspring from the male of the species, right? So she's protecting herself and her own body, so she has to be a bit larger. She's typically protecting the offspring, sometimes from just, other predators in the environment, but oftentimes from the actual male of their own species. So the female has to be larger to be able to do that. And then with whales, it's interesting basically because the matrix they're living in is very different. They're in water, that the male being a little smaller allows it to be a little more agile for like reproductive reasons, getting around a little easier. So that's why you see the male being a little bit smaller. Let's see, just a few more slides on the insect parts, right? Okay, so now slide 49, you'll see there's something called runaway sexual selection. So the example, a really good example of this is like the peacock and the peahen, right? So the male is the one with all of these giant elaborate feathers, colors, and a lot of different reasons why we see this. But we often use them as a reference to this concept called runaway sexual selection. And this is a question mark. Does this thing really exist? The idea is that sometimes, in sexual selection, females will select a particular trait into absurdity. And so in this case, the females have to continue to select the longest, largest feathers, because and it's indicating something evolutionary to them. It's probably indicating like their mate is healthier or something like that. But once again, we as females are getting blamed for something. But this is the question mark I have here, is that really something that's happening? Are females just selecting something into absurdity and then like it's a detriment to the male? That's not really that. At the surface level, that might be what it looks like. If you go to the next slide, you'll see slide 50, there's something called costly signaling. So this actually can be used to the benefit of the male. So the female can select a feature and maybe that feature ends up becoming this extreme version of itself, but the males will often use this to their advantage. So the male peacock basically is like, well, look at this giant tail I have. I can't even fly anymore, but look, I'm still here. I've avoided the predators. Like, doesn't that tell you something about myself, that I'm amazing? So this is called costly signaling, and this presents in a lot of different ways in mammals. Males might have a feature or a behavior where it looks as if it's a detriment to them, and females might select for it, but in reality, they actually use it to show more females that they're actually a better choice. So let's see, what else do I have? I think I just have, oh, in class, we would go over some of this in a little more detail, these last like 10 slides, but we can't really have that like back and forth in class. We would all have interesting discussions. I'd ask you, personal examples. We would all share, some of our dating history and all like modern human dating in terms of like sexual selection and evolution is always very interesting. So we can't really have those conversations here, but I left those slides in as kind of food for thought. So if you wanted to kind of go through those and look at, like as an example on slide 50, let me look, like slide 53, what about all the cultural things like for humans, if we're talking just about humans, the cultural factors, clothing, what kind of occupation you have, what material possessions you own, how do you display those? When do you display those? Are those truthful or are they a lie? And how all of that kind of plays out with how culture and evolution, like, and biology kind of work, about how our dating systems, kind of work. And then the last bit, it's about life history strategy, but I don't think I even really ask any questions about that. So I'll just leave that. But oh, my computer's about to die. Let me just plug it in real quick. But yeah, that's kind of wrapping up this one. And so this one's a long one, right? In class, we would probably spend like 3 or 4 days going over the entire sexual selection thing. So we did this in 2 videos. of approximately the same length, about 45 minutes. So, okay, I will see you guys on the next one.